Hello and welcome back. Let's talk about parametric surfaces. So in our first video on this series, we talked about regular 3D surfaces. Now we're going to talk about how to make these into parametric equations of just two variables instead of three, so that we can use those and apply those to things later on in Calc 3. So the first example we could have is any explicit function of, say, x and y, or any two variables. It could be a function of x and z, or z and y as well. But remember that usually this means z equals f of x, y, and yeah, so those are going to equal some function of x and y, of course. So we represent our parametrization as a r as a function of, in this case, x and y. And this is just going to equal, we're going to write it as a vector because of this line up here. In this case, x equals x, y equals y, and z equals f of x and y. So that's a pretty simple one, pretty self-explanatory. It's the same way we had in 2 dimensions when we had a r of t, and if we had an explicit function of, let's say, y equals x squared, we would have x equals t and y equals t squared. Same idea, we're just introducing another variable. Let's take a look at something a little tougher. So next is cylinders. We remember cylinders look like this. Let's say it's along the z-axis, although we could change our variables very easily. We know that there's circles in the bottom, so this gives us a hint. We know that we'll make this a function of theta and z. So we know that for this case, x and y are just going to be a circle. So that's just going to be your radius times cosine of theta for x, your radius times sine of theta for z, and z is just going to equal z again because it just goes up and down. It just stretches this circle along the z-axis. And as we remember with parametric equations, we can easily say, let's say this span from z equals 0 to 6, we could say theta runs from 0 to 2 pi, and z runs from 0 to 6. If we wanted half of it, we'd have theta running from 0 to pi, and so on. So that's another pretty easy one. Let's talk about some more circular type of things. Let's talk about cones. So cones look like this. Of course, we talked about this in our earlier video, but remember that they can also go down like this. And so, once again, we are going to have a sine theta and cos theta, and we're also going to have a z again. So let's just write our cos theta, our sine theta. I'm going to make a little space for something here. What we're going to do is put our z here, because say at z equals 0, we want the circle to have an area of 0, or x and y to have distances of 0. So we times them by z. So that's cones. We only really have one left. What we have left is spheres. Now these are a little tougher. I'm not going to draw a sphere because we all know what a sphere looks like, and we all know that I'm not the best at drawing them. But let's take a look at this. Well, as we remember from our spherical coordinates, for spheres, we will have to use 2 angles. And so what we're going to have is we're still going to have our regular cos theta. We're going to have to times it by something so that we know where it is within the circle along the z. We're still going to have our regular sine theta, but we're also going to have a z parameter. And turns out, since these x and y depend on the height of z, they depend on the sine of phi. And so basically what these are saying is, at the top of the circle, we remember our phi comes off of the z-axis. At the top of the circle, these are 0. And at the very widest part of the circle, where phi equals pi over 2, sine phi will equal 1, we'll just have a regular circle. And of course we have sine phi's, so we're going to have a cos phi here. And that's simply because our z is this portion here. The adjacent SOHCAHTOA. Very simple stuff. Now this is, oh, I forgot my S. Cos phi, not co-phi. But this is a pretty simple video. Some of these might have to be memorization, but if you can understand why they work, I hope that they become a lot simpler. And I hope this video sort of helped with figuring that out. And I'll catch you in the next video where we talk about line integrals. Something I love so much that I actually have a 3D representation of it on my desk. So I hope to see you in that next video. Thanks for watching.